Welcome to my presentation video on UPS. My name is Martin Lavachka, and in this video I'm going to talk about the availability and quality of electrical power, availability and batteries, system earthing arrangements for installations comprising UPSs, choice of protection schemes, installation, connection and sizing of cables, the UPSs and their environment and complementary equipment. Availability and quality of electrical power. The disturbances of availability and quality of electrical power may affect safety of human life, safety of property, and the economic viability of a company or production process. Disturbances must therefore be eliminated. Many technical solutions contribute to this goal with varying degrees of effectiveness. These solutions may be compared based on two criteria: availability of the power supplied and quality of the power supplied. The availability of electrical power can be thought of as the time per year that power is present at the load terminals. Availability is mainly affected by power interruptions due to utility outages or electrical faults. There are solutions to limit the risk: division of the installation to use several different sources rather than just one, subdivision of the installation into priority and non-priority circuits, where the supply of power to priority circuits can be picked up if necessary by another available source, load shedding as required so that a reduced available power rating can be used to supply standby power, selection of a system earthing arrangement suited to service continuity goals, for example IT system, and selectivity of protection devices to limit the consequences of a fault to a part of the installation. Note that the only way of ensuring the availability of power concerning utility outages is to provide, in addition to the above measures, an autonomous alternate source, at least for priority loads. This source takes over from the utility in the event of a problem, but two factors must be taken into account: the transfer time must be acceptable to the load, and the operating time during it can supply the load. The quality of electrical power is determined by the elimination of the disturbances at the load terminals. An alternate source serves to ensure the availability of power at the load terminals. However, it does not guarantee in many cases the quality of the power supply. Today, many sensitive electronic applications require an electrical power supply that is virtually free of disturbances, without outages, and with tolerances that are stricter than those of the utility. This is the case, for example, for computer centers, telephone exchanges, and many industrial process control and monitoring systems. These applications require solutions that ensure both the availability and quality of electrical power. The UPS solution. The solution for sensitive applications is to provide a power interface between the utility and the sensitive loads, providing a voltage that is free of all disturbances present in utility power and in compliance with the strict tolerances required by loads, and available in the event of a utility outage within specified tolerances. UPSs satisfy these requirements in terms of power availability and quality by supplying loads with voltage complying with strict tolerances through the use of an inverter, providing an autonomous alternate source through the use of a battery, and stepping into the replace utility power without any interruption in the supply of power to the load through the use of a static switch. These characteristics make UPSs the ideal power supply for all sensitive applications because they ensure power quality and availability whatever the state of utility power. A UPS comprises the following main components: rectifier that produces DC power to charge a battery and supply an inverter, inverter that produces quality electrical power free of all utility power disturbances and within tolerances compatible with the requirements of sensitive electronic devices, battery that provides sufficient backup time to ensure the safety of life and property by replacing the utility as required, and static switch, a semiconductor-based device that transfers the load from the inverter to the utility and back without any interruption in the supply of power. There are three types of static UPSs: UPS with passive standby operating mode, UPS with line interactive operating mode, and UPS with double conversion operating mode. Standard IEC 62040 defines the following terms: primary power, which is power normally continuously available that is usually supplied by an electrical utility company but sometimes by the user's generation; standby power, which is power intended to replace the primary power in the event of primary power failure; and bypass power, which is power supplied via the bypass. Practically speaking, a UPS is equipped with two AC inputs, which are called the normal AC input and bypass AC input in this guide. The normal AC input, noted as mains input 1, is supplied by the primary power. The bypass AC input, noted as mains input 2, is generally supplied by standby power. UPS operating in passive standby mode has the inverter connected in parallel with the AC input in a standby. In normal mode, the load is supplied by utility power via a filter that eliminates certain disturbances and provides some degrees of voltage regulation. The inverter operates in passive standby mode. In battery backup mode, when the AC input voltage is outside specified tolerances for the UPS or the utility power fails, the inverter and the battery step in to ensure a continuous supply of power to the load following a very short transfer time. The UPS continues to operate on battery power until the end of battery backup time or the utility power returns to normal, which provokes the transfer of the load back to the AC input. This configuration is a compromise between an acceptable level of protection against disturbances and cost. It can be used only with low power ratings. It operates without a real static switch, so a certain time is required to transfer the load to the inverter. This time is acceptable for certain individual applications, but incompatible with the performance required by more sophisticated sensitive systems. Also, the frequency is not regulated and there is no bypass. UPS operating in line interactive mode has the inverter connected in parallel with the AC input in a standby configuration but also charges the battery. It thus interacts with the AC input source. In normal mode, the load is supplied with conditioned power via a parallel connection of the AC input and the inverter. The inverter operates to provide output voltage, conditioning, and charge the battery. The output frequency depends on the AC input frequency. In battery backup mode, the inverter and the battery step in to ensure a continuous supply of power to the load, following a transfer without interruption using a static switch that also disconnects the AC input to prevent power from the inverter from flowing upstream. This type of UPS may be equipped with a bypass. If one of the UPS function fails, the load can be transferred to the bypass AC input. This configuration is not well suited to the regulation of sensitive loads in the medium to high power range because frequency regulation is not possible. For this reason, it is rarely used other than for low power ratings. UPS operating in double conversion mode has the inverter connected in series between the AC input and the application. In normal mode, all the power supply to the load passes through the rectifier and inverter that together perform a double conversion. In battery backup mode, the inverter and the battery step in to ensure a continuous supply of power to the load following the transfer without interruption using a static switch. In bypass mode, the load can be transferred without interruption to the bypass AC input in the event of UPS failure, load current transients, or load peaks. However, the presence of a bypass assumes that the input and output frequencies are identical, and if the voltage levels are not the same, a bypass transformer is required. For certain loads, the UPS must be synchronized with the bypass power to ensure load supply continuity. Furthermore, when the UPS is in bypass mode, a disturbance on the AC input source may be transmitted directly to the load because the inverter no longer steps in. Another bypass line, often called the maintenance bypass, is available for maintenance purposes. It is closed by a manual switch. In this configuration, the time required to transfer the load to the inverter is negligible due to the static switch. Also, the output voltage and frequency do not depend on the input voltage and frequency conditions. This means that the UPS, when designed for this purpose, can operate as a frequency converter. This is the main configuration used for medium and high power ratings. Batteries. A battery is made up of interconnected cells that may be vented or of the recombination type. There are two main families of batteries: nickel-cadmium batteries, lead-acid batteries, vented cells equipped with ports to release to the atmosphere the oxygen and hydrogen produced during the different chemical reactions, and top off the electrolyte by adding distilled or demineralized water. Recombination cells is the gas recombination rate is at least 95% and they therefore do not require water to be added during service life. The main types of batteries used in conjunction with UPSs are sealed lead acid batteries that are used 95% of the time because they are easy to maintain and do not require a special room, vented lead acid batteries, and vented nickel cadmium batteries. The above three types of batteries may be proposed depending on economic factors and the operating requirements of the installation with all the available service life durations. Capacity levels and backup times may be adapted to suit the user's needs. The proposed batteries are also perfectly suited to UPS application in the sense that they are the result of collaboration with leading battery manufacturers. The selection of backup time depends on the average duration of power system failures, any available long-lasting standby power, and the type of application. The typical range generally proposed is 10, 15, or 30 minutes, or it may be customized. For computer applications, battery backup time must be sufficient to cover file saving and system shutdown procedures required to ensure a controlled shutdown of the computer system. Generally speaking, the computer department determines the necessary backup time depending on its specific requirements. For industrial processes, the backup time calculation should take into account the economic cost incurred by an interruption in the process and the time required to restore. Here we can see a table that sums up the main characteristics of the various types of batteries. Increasingly, recombination batteries would seem to be the market choice for no maintenance, easy implementation, and installation in all types of rooms. In certain cases, however, vented batteries are preferred, notably for long service life, long backup times, and high power ratings. Vented batteries must be installed in special rooms, complying with precise regulations and require appropriate maintenance. Depending on the UPS range, the battery capacity and backup time, the batteries sealed type and housed in the UPS cabinet, sealed type and housed in 1 to 3 cabinets, vented or sealed type and rack mounted. In this case, the installation method may be on shelves. This installation method is possible for sealed batteries or maintenance-free vented batteries that do not require the topping up of the electrolyte. Tire mounting. This installation method is suitable for all types of batteries and for vented batteries, in particular as level checking and filling are made easy. Or in cabinets, this installation method is suitable for sealed batteries. It is easy to implement and offers maximum safety. System earthing arrangements for installations comprising UPSs. Application of protection systems stipulated by the standards in installation comprising a UPS requires many precautions as the UPS plays two roles: a load for the upstream system and power source for the downstream system. Or when the battery is not installed in a cabinet, an insulation fault on the DC system can lead to the flow of a residual DC component. This component can disturb the operation of certain protective devices, notably RCDs used for the protection of people. All installations satisfy the applicable requirements because the equipment is housed in cabinets, providing a degree of protection IP20. This is true even for the battery when it is housed in a cabinet. When batteries are not installed in a cabinet, certain measures should be implemented. On this slide, you can see a table with the main characteristics of system earthing arrangements. On this slide, you can see a diagram that shows all the essential points that must be interconnected, as well as the devices to be installed to ensure installation conformity with the safety standards. Choice of protection schemes. The circuit breakers have a major role in installation, but their importance often appears at the time of accidental events that are not frequent. The best sizing of UPS and the best choice of configuration can be compromised by a wrong choice of only one circuit breaker. The graph here shows how circuit breakers are submitted to a variety of situations. The selected rating for the circuit breaker must be the one just above the rated current of the protected downstream cable. The breaking capacity must be selected just above the short circuit current that can occur at the point of installation. The table below indicates how to determine the IR and IM thresholds to ensure selectivity depending on the upstream and downstream trip units. Time selectivity must be implemented by qualified personnel because time delays before tripping increase the thermal stress downstream. Caution is required if the tripping of circuit breaker 2 is delayed using the threshold time delay. Energy selectivity does not depend on the trip unit, only on the circuit breaker. Installation, connection, and sizing of cables. The low power UPSs for microcomputer systems, for example, are compact, ready to use equipment. The internal wiring is built in the factory and adapted to the characteristics of the devices. For the other UPSs, the wire connections to the power supply system, to the battery, and to the load are not included. Wiring connections depend on the current level as indicated in the diagram. The input current of mains 1 from the power network is the load current. The input current of the charger rectifier depends on the capacity of the battery and the charging mode, the characteristics of the charger, and the efficiency of the inverter. The current IB is the current in the connection of the battery. All these currents are given by the manufacturers. The cross-section of cable depends on permissible temperature rise, and permissible voltage drop. For a given load, each of these parameters results in a minimum permissible cross-section. The larger of the two must be used. When routing cables, care must be taken to maintain the required distances between control circuits and power circuits to avoid any disturbances caused by high-frequency currents. Permissible temperature rise in cables is limited by the withstand capacity of cable insulation. Temperature rise in cables depends on the type of core, the installation method, and the number of touching cables. The maximum permissible voltage drops are 3% for AC circuits and 1% for DC circuits. This selection table indicates the voltage drop for three-phase circuits in percent for a circuit made up of 100 meters of cable. If the voltage drop exceeds 3%, increase the cross-section of conductors. This selection table indicates the voltage drop for DC circuits in percent for a circuit made up of 100 meters of cable. If the voltage drop exceeds 1%, increase the cross-section of conductors. In three-phase systems, the third-order harmonics and their multiples of single-phase loads add up in the neutral conductor. For this reason, the following rule may be applied. Neutral cross-section equal to 1.5 times phase cross-section area. The UPSCs and their environment. The UPSCs can communicate with electrical and computing environments. They can receive some data and provide information on their operation in order to optimize the protection, to remotely control, or to manage the installation. The operator has a building and energy management system that allows it to obtain and save information from UPSCs to provide alarms and events and to take action. This evolution towards compatibility between computer equipment and UPSCs has the effect of incorporating new built-in UPS functions. Complementary equipment. A two-winding transformer included on the upstream side of the static contactor of circuit 2 allows a change of voltage level when the power network voltage is different to that of the load, and a change of the system of earthing between the networks. Moreover, such a transformer reduces the short circuit current level on the secondary side compared with that on the power network side, and prevents third harmonic currents that may be present on the secondary side from passing into the power system network, providing that the primary winding is connected in delta. The UPS system includes a battery charger that is controlled by thyristors or transistors. The resulting regularly chopped current cycles generate harmonic components in the power supply network. These undesirable components are filtered at the input of the rectifier and for most cases, this reduces the harmonic current level sufficiently for all practical purposes. In certain specific cases, however, notably in very large installations, an additional filter circuit may be necessary. For example, when the power rating of the UPS system is large relative to the MV-LV transformer supplying it, the LV busbar supply loads that are particularly sensitive to harmonics, or a diesel-driven alternator is provided as a standby power supply. In such cases, the manufacturer of the UPS system should be consulted. Communication with equipment associated with computer systems may entail the need for suitable facilities within the UPS system. Such facilities may be incorporated in the original design or added to the existing systems on request. We've come to the end of this presentation. Thanks for watching.